Okay, we're on the last slide of this section. We're talking about the central limit theorem. We already said something about it, but I'm saying it again. The central limit theorem says x bar has an approximately normal distribution if n is large. You might ask, how large is large? Here we go. Here the rules of thumb are n should be bigger than 10 for symmetric mound-shaped population. So if you have data that appears to be symmetric and mound-shaped, but maybe not exactly normally distributed, if the sample size is bigger than 10, we can assume x bar is normal enough for us. And then if you have data that's obviously not normal, as long as you have a sample size bigger than 40, then x bar is going to look quite normal indeed, and we can use z-tables and so on to do calculations about x bar. So we'll do an example here of the kind of calculations using the central limit theorem to allow you to compute things when you don't have enough information to do it otherwise for single values. Suppose we sample n equal 50 values from a population which is not normally distributed, but we happen to know the mean is 46 and sigma is 85. We're sampling 50 values. Let's find the probability of the sample mean will fall between 43 and 48. 46 is the mean for the x bar, so that's 2 above 46 and 3 below 46. So it's near the middle of the distribution of x bar. So we go ahead and compute z values for each of those. So here's z for 43, 43 for x bar, 46 for mu, sigma is 8.5, n is 50, there it is. I get minus 2.5. And I go to the tables, and I get 0.062. That's the chance of being less than minus 2.5 standard deviations away from the mean in a normal distribution. There's almost no chance of being smaller than that. So this distance, 3 units away, because n is 50, is a long distance indeed. It's pretty hard to be smaller than 43 for x bar with a sample size of 50. We'll do the same calculations here for 48. So 48 for x bar, 46, that's 2 units. Here's 8.5 over the square root of 50. That's just something like 1, right? Isn't that right? Square root of 50 is like 7. So that's 2 over something like 1, a little bit bigger than 1. We get 1.66. The chance of being less than 1.66 in a standard normal distribution is 0.9519. So it's pretty far off to the right, too, because you have a 95% chance of being less than that. And then to find the chance that you're between those two values, you take those two probabilities and you subtract the smaller one from the big one. So 9515 minus 0.0062, you get 9453. All right. So we've been doing those calculations for a while, but now it's in a different context. We're finding probabilities. We're using the central limit theorem to allow us to find probabilities in situations where the population is not normally distributed, because we're taking the sample mean and doing calculations with it. And the sample mean will be about approximately normally distributed if n is bigger than 40, sort of no matter what, and if n is bigger than 10, if the population looks symmetric and mound-shaped. So that's the end of chapter 15 for us, and you should be ready to start doing the homework, which I will just now put it out there, and also will send out my notes that I use to make these slides, and then we'll see how that goes. And we'll be meeting in the virtual world Monday at the usual class time. We'll see you then.